and magnitude is a measure of the seismic waves. So when I show you a picture of a graph of seismic waves here, this one has pretty great magnitude. Those are really tall waves. This one probably doesn't have a very big magnitude. Those waves are very small. It wouldn't be as big of an earthquake. All right, so there are 3 ways to measure an earthquake. The first is the Richter scale. You've probably heard of it. It's actually outdated, but the media still uses it because they're familiar with it, as so are their viewers, you guys. It's based on, again, the amplitude or height of the largest wave. So when you're looking at these graphs, the largest wave is going to have the largest amplitude and get the highest rating on the Richter scale. It's very useful for small, shallow earthquakes, but again, it's not the most scientific. It's pretty outdated. It's just familiar. Number 2 is the moment magnitude scale. It is the most widely used by scientists. It estimates how much energy a rock can store before that energy has to be released. So remembering the elastic rebound lab where we had the wood blocks attached to rubber bands and you pulled the pencil and the rubber band stretched, those rubber bands held elastic energy. That energy was deferred into the wood block, and then as you were pulling, the wood block finally rebounded back towards you because all that energy was finally too much. So that's moment magnitude. It estimates how much energy a rock can store before that energy must be released. It is calculated using 3 methods. Number 1, average amount of movement on a fault. So how much that fault, does it usually move only a little? Does it usually move a lot? Area of surface break. Is there a large crack at the surface when it moves, or there a small crack? And finally, the strength of the broken rock. Are we breaking granite? Are we breaking obsidian? Or are we simply breaking calcium? You know, if it's calcium, it's going to break really easily. You don't have to have a lot of energy to do that. So a higher magnitude earthquake would be one that includes a lot more energy used. The third and final is the modified Mercalli scale. It rates earthquakes based on the effects felt at different locations. So that's that part. Do you guys want me to stop talking? Because I so want to stop talking and go home. It's like 4 o'clock. I'm tired. I need sleep. I need food. We were promised pizza at a meeting today. No pizza. Hungry. Cranky. Tell you what, you let me get through this whole part on locating an earthquake, and then we will do the graphs together in class because I'm done and you are too. So, locating an earthquake. Use the difference in arrival times of P waves and S waves. You need a visual aid for this because it is just too much. So let me grab that. Look, at everything's at my disposal here. Here it is. So this graph is an awful graph, and it's backwards and upside down. So here you go. You have a line representing P wave. You have a line representing S wave. What you're looking for is the distance in between. All right, so but you're going to, okay, start over. Time in minutes is down here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 minutes. Distance in kilometers is on the side. Notice this is not usual. At the top, it's 1,200. At the bottom, it's 2,400. So we are going the opposite of your expectation. All right. What you'll be doing is you'll be using a little note card. Here's mine. That's what I've done is I've written 1, 2, 3, 4, 5 on there in the same scale as what is on the paper. So basically, I copied it. And I did another one, and I can't find it, but I made all the tiny little marks in between 0 and 1 to make it easier for me when I get to the better, more specific time differences. So anyways, we're going to go back to that earthquake number 10, which was exactly 4 minutes for this example. So I want to find my number 4, and my 0 was, of course, right here. So you're going to take your little graph, and you're going to put your P wave line at 0. Okay, that's there. But my S wave line right now is at like just past 3. So I'm going to bring this down until both the 0 and the 4 are intersecting lines. Do I have it? I think I've got it. So my measurement for that is, how many lines up? 1, 2, 3, 4. 1, 2, 3, 4. Right here. I'm at 2,400, so that's about 2,300 kilometers, because we had a distance of 4 minutes. Okay, 4 minutes on here. So that's what you guys need to do. You need to make a note card with 5 minutes. You need to use this. You need to make the note card on the same scale. All right, and then you need to look at your time. You need to find out where the exact intersection of both is. And what I do want you to do that is not on this note card is make the 10 tiny little marks in between to help you so you don't have to do a rough guess and get the questions wrong. Okay, let's finish. So, use the difference in arrival time of P and S waves. P waves move faster than S waves. The greater distance waves travel from the epicenter, the farther apart the waves become. The travel time graph shows distance from each seismic station to the epicenter. Epicenter is calculated using 3 things. You need your travel time graph. You need data from 3 different seismic stations. Here I have 1, 2, 3, 4, 5, 6, 7, more than necessary. Lastly, a map, including the locations you have data for. All right, so you'll use those 3 things together. You'll interpret the seismic data. You will find out how much distance is between them based on the travel time graph, and then you will plot 3 earthquakes. You'll plot 3 earthquakes on here using a compass. And guess what? Mosul did this one, and he made the same mistake I did. Do better than us. All right, that's all for now.